So I got this speaker set up here. I'm going to be blowing a couple of speakers that are bad. I was going to use this for a test jig setup, but these are actually, I don't know if you can hear it, but that one is actually has a distorted coil on the inside, and then this one, just because they're not matching, or they're not going to be matching. I've got, and I just have my my 18 amp computer power supply, which is going into this Pioneer 760 watt amplifier, and I'm just gonna have a little fun here. Nope. That one went. Yeah. Smells. Oh, that one actually froze. What about this guy? Nope, that wouldn't be. Well, maybe. Because I also have that tweeter hooked up. Nope, they're dead. Let's switch over to these. Nope. Yeah, you see the smoke? It's a smoking! I'll press on it. See the smoke still residing on the inside there. Damn, that thing got hot. Oof. Yeah, those came out of an Altec Lansing computer speakers, and they didn't sound very good. Of course, this one was blown, and this one was not blown, but it was out of ohm spec. I think these are 4 ohm speakers, and it was reading like 1.5 ohms, so it was really close to be getting blown. That's why they probably blew so fast. So yeah, of course, I think they were rated at like 10 watts, and I just ran probably a good maybe 200 watts through them. Before I continue with this, I wanted to show you guys something. This is a 4 ohm 10 watt speaker. This speaker came out of a Samsung home theater in a box system, and I had used this in my car for a long time to be the external speaker for my scanner, my radio scanner. But the home theater in a box from Samsung said that it was like, 100 watts per channel, which there's no way it was 100 watts per channel if there was a 10 watt speaker in here. Even if they put a resistor across it, there's no way it would have blown if it was actually, a 100 watt system. So that's why home theater and the systems aren't very truthful. But yeah, let's see what this thing can take. he's done. That was pretty loud. That was probably about halfway on my system, or not my system, my... Woo! That is burning. Okay, let me turn the amp off. And gonna plug it here. That one was a little more fun. The wires for the power supply are just slightly warm. But yeah, let me get the tape off this thing and take a look inside. Okay, so wasn't able to get any smoke that got trapped in here, but I was sure there was such thing as smell-o-vision, because this particular speaker smells horrible. And you can see that the coil that's leading into the inside of the magnet is actually like fried to the actual magnet, and that's pretty interesting. You can see, yeah, here's the discoloration here. Focus on my hand. There you go. See the discoloration on that coil. So, not bad for a 10-watt speaker. So, these are the speakers that are out of my Emerson Boombox. It was kind of a failed project, but I did get the AM/FM board out of it that I'm going to be using for another project. And I already blew one of them. I thought I was recording, but I forgot to press the record button on the camera, which is really stupid because half the time I'm looking at my camera and the other half I'm not, but for some reason that time I didn't. But you can hear that one already blew. So, let's go to... Oh, there it goes. See what it smells like. No? Well, a little bit. Yeah, that one's pretty froze up. So I bet a lot of people didn't know this. You can hook up a fan to a speaker output, and I'm going to see if my microphone can actually pick this up. I'm going to turn up the volume here. I'll see if maybe I have to increase the volume in the video. Let's go. That's enough of that one. Here's another old fan. This is one from work that was in a really old printer. And I'm just playing the bass I Love You. See if you guys can hear it. So the next thing that I am going to try and blow or destroy are these fans. I just have them hooked up to this variable power supply, and let me unplug this before I blow it. But this power supply can be able to go up to 32 volts DC. So we're going to get this hooked up. We're going to flip this around. This is a 12 volt 0.6 amps, so just a little more than half of an amp. We're going to see. Okay, we're at 6 volts. $12.7, 13 volts. Actually, this one doesn't have a guard because the guarding around it, or the brace, actually broke. So, yeah, 12, 14. Good God, this Intel fan can take some. Let me put something in front of this before I give myself some shrapnel pieces of plastic. Let me find a way to get this. Oh, I just killed it. What was that, 21 volts? Well, it's not hot. I wonder if it had a voltage regulator in there. Let's see if it, will start back up. Nope. It's dead. Well, let me unplug it from power. Plug it back in. Try it again. Nope, it's dead. So we know that an Intel fan can take up to 21 volts before it dies. So here we have a 24 volt DC fan. We may not get this one to blow because, you know, it's obviously a lot more. It starts up at about 6 volts. 7 volts. When you hear the relay clicking on the power supply, it's probably because it has like a secondary system for the when you get above 12 volts. Let's see here. Making some weird noises. This is a crazy little fan. It wants to literally fly away. Let's put this down. Nope. So here's another fan that came out of a printer. Came out of a really large printer. It's 18 volts DC and it draws up to 100 milliamps, so almost an amp. And you can see it's one of those. I call them a cyclone fan. It just sucks in and then blows out on one side. So we're gonna see what this thing can take. I think it sounds like a jet. It's a lot of air. It is pushing a lot of air. Alright, let's go for it. That thing is crazy. Alright, let's kill it. Let's see if it's getting hot. No, it's not getting hot. Alright. It's like it reminds me of air traffic control. Says you are ready for takeoff. Okay, that sucks. My battery died literally when it was pushing so much air. It was actually moving the fan. And this thing is not light by any means. It probably weighs a good 3 or 4 pounds. But let's try and see if we can get it to go again. See, at 18 volts, it is drawing about 0.8 amps.